Mathematics for freshman students. Part 29. In these parts, we will discuss different exercises on basic trigonometric identities and radian degree conversions. This part is useful for both natural and social students, so that don't forget to subscribe, like, comment, share my channels. Now let us start from questions number 1. Such that converts the given angle from radians to degrees. A pi over 3. Now to convert this pi over 3 to this is in radian form to degree form, simply we use or we simply multiply by 180 over pi, or in other ways, since pi is 180 degrees, therefore pi is the same as 180 degrees, so that we can substitute pi by 180 degree, so that pi over 3 is the same as 180 degree over 3, since pi is the same as 180 degree. So 180 degree over 3 is the same as 60 degree. Or in other ways, theta over 180 degree is equals to pi over 3 over pi. Or in other ways, simply multiply this by 180 degree over pi. Anyways, we need to find theta. So theta is the same as 180 degree times pi over 3 the whole over pi. Then pi is cancelled by pi. Then 180 degree over 3 is, which is 60 degree. B minus 5 pi over 2. As I told you, that pi is the same as 180 degree. So substitute pi by 180 degree. We have that minus 5 times 180 degree over 2. Since 2 by 2, 2 by 180 degrees, which is 90, therefore minus 5 times 90 degree, the same as minus 450 degree. Or another way is using theta over 180 degrees equals to minus 5 pi over 2 over pi. So that's theta is equals to minus 5 pi over 2 times 180, minus 5 over 2 times 180 degrees, the same as minus 450 degree. C minus 4 pi over 3. This implies that minus 4 pi over 3 is equals to minus 4 times 180 degree the whole over 3. Then 180 degree by 3 is the same as 60 degree. Then we have minus 4 times 60 degree equal with minus 240 degree. Number 2, convert the given angle from degrees to radians. The degree is given here a 315 degree or 315 degree. Now to find this 350 degree to convert this 350 degree to radians, simply we multiply pi over 180 degree. Or in other ways, substitute pi or using theta over pi, which is the same as 350 degree over 180 degree. We have to find theta, then theta is the same as, which is 350 degree times pi the whole over 180 degree, which is the same as, by simplifying this, we have 35 over 20 times pi is equals to 7 over 4 times pi. Implies that theta is equals to 7 over 4 times pi. The other thing is B minus 40 degree. Minus 40 degree is the same as theta over pi times is equals to minus 40 degree over 180 degree, which is the same as, by simplifying this, we have minus 4 over 18. And again, when we simplify this minus 4 over 180 degree, 18 by 2, we have minus 2 by 2, 9. Then we have minus 2 over 9. And we have here pi, then this is the same as minus 2 over 9 pi. C 330 degree. This implies that theta over pi is equal to 330 degree over 180 degree. When we simplify this 330 degree over 180 degrees, then 0 comes 0 degree 0 by 0. And we have 33 over 18. Again, when we simplify by 3 here, 11 over 6 implies that then multiplying by pi or multiply both sides by pi, we have that means theta over pi is equals to 11 over 6, and multiply both sides by pi, we have theta is equals to 11 over 6 times pi. Or in other ways, to convert those degrees to radians, simply multiply the given degree by pi over 180 degree. Or we also, to convert those radians to degree, simply multiply 180 degree over pi, the given radians, then multiply the given radians by 180 degree over pi, then we obtain the required degree. Number 3, verify the following identity. A. Sin x minus cos x times cosec x plus sec x is equals to tan x minus cot x. Now, to verify this, that means starting from the left hand side, then we obtain the right hand side. Or to show this or to verify this, right, starting from the right hand side, then we obtain the left hand side. Now, for the time being, let us start from the left hand side. That means sin x minus cos x times cosec x plus sec x. As we know that cosec x is, which is the reciprocal of sin x, and sec x is the reciprocal of cos x. That means sin x is, cosec x is the same as 1 over sin x, and sec x is the same as 1 over cos x. So that's sin x minus cos x times cosec x plus sec x is the same as sin x minus cos x the whole times 1 over sin x plus 1 over cos x. Now here, by taking the DCF of this 1 over sin x plus cos x, we have that sin x minus cos x the whole times sin x plus cos x the whole over sin x times cos x. This is the same as sin x minus cos x the whole time sin x plus cos x the whole over sin x times cos x. Then when we multiply this, we have that sin square x minus cos square x the whole over sin x times cos x, using the formula a minus b times a plus b, the same as a square minus b square. So we have sin square x minus cos square x the whole over sin x times cos x. Again, by simplifying this, we have that sin square x the whole over sin x cos x minus cos square x over sin x cos x. Again, when we simplify this, we have sin x over cos x minus cos x over sin x. But we know that sin x over cos x is tan x, and cos x over sin x is cot x. Therefore, we have tan x minus cot x. Therefore, sin x minus cos x times cosec x plus sec x is the same as tan x minus cot x. B. Sec square x minus cos square x is equal to tan square x minus cot square x. Now, from the trigonometric identity, we have that sec square x is the same as tan square x plus 1, and cosec square x is equal to cot square x plus 1. From these equations, we have that sec square is the same as tan square x plus 1, and cosec square x is equal to cot square x plus 1. Then by subtracting this, we have that sec square x minus cos square x is equal to tan square x minus cot square x, which is the required result. Number 4. Prove the identity 2 and 3. From that means the given identities, which is identity number 1 is sine square x plus cos square x is equals to 1, and identity 2 is tan square x plus 1 is equals to sec square x. Identity number 3 is cos square x plus 1 is equals to cosec square x. Now here we need to prove identity number 2 and number 3. Now to prove number 2 and number 3, we use identity number 1. That means sine square x plus cos square x is equals to 1. Hence, from the first we have that sine square x plus cos square x is equals to 1. Then dividing both sides of these equations by cos square x, we get sine square x plus cos square x the whole over cos square x is equals to 1 over cos square x. This implies that sine square x over cos square x plus cos square x over cos square x is equals to 1 over cos square x. Implies that tan square x plus 1 is equals to sec square x, which number 2 is, which is already proved. Again, dividing both sides of these equations by sine square x. That means dividing identity number 1 by sine square x means that sine square x plus cos square x is whole over sine square x is equals to 1 over sine square x. Implies that sine square x over sine square x plus cos square x over sine square x is equals to 1 over sine square x. Implies that 1 over cos square x is equals to cosec square x, which is a required result. Thanks for watching my video, but don't forget to subscribe, like, comment, share my channels.